All right. So, everybody, welcome to binarysearch.com and another weekly contest. Yeah, we are back. We will try to solve all the problems today and, more importantly, walk you through the solutions. Because that's the whole point of these videos, right? So that you can watch me solve some problems and learn something from it. And also, after the contest, we'll have hopefully regular binary search chess tournaments on Lichess. So let's see. I'm not sure if that one gonna be recorded, but in case you are interested in chess, not only in programming, I guess that's another reason why you could want to join this platform and probably solve some problems here. So I'm gonna make myself a bit smaller, not to cover anything important. Yeah, certainly don't want to cover run and submit buttons. Yes, guess I can make it something like this. Yeah, like this. Yeah, should be fine. So we'll code in Python. Hopefully it goes well for us. Let's see. Problems should get loaded in a second. But okay. Again, string 10 digits rather is a summary, so we can have one pair of the same digits and the rest. From n number of triples of the same. What? One pair of the same digits and the rest of the numbers form any number of triples of the same digits. Oh, okay. I paste this thing. I don't really know. Let's try this. Okay, got it. Find local peak equal. We're given a list of integers. Return an index of every peak in the list sorted in descending order. An index I is called the peak if all three conditions are true. Index of every peak in the list sorted in descending order. The next number on its right is different from. Okay, so if several numbers are equal, then they are all peaks. Okay. That sort of complicates things, but not really. I guess we just. How about that? If we group by. No, actually, I believe we want. To group it in a list. We want to have an index list of answers. Oh, okay. I guess this works, sort of. I also want G0, okay, is greater than G I plus 1 that I have it here. Like that, I believe is correct. Let's check. The first number in first element is value. No, actually, I want to make it like that. And then I just want the same condition, but more careful here. Here I want to go backwards only, and here I want to go both ways. Wait, what? Why? It doesn't exist. Oh, okay, so here, oh, whatever. Has no lamb. But I made you a list. Okay, maybe I should have made it a list explicitly. Okay. Oh, is it? We has no lambs. Okay, I got it. I got it. Plus equal lamb list. I'm pretty sure this was my mistake. And well, actually, I should have just converted it straight away. Huh? Okay, probably I just want to replace this with V. And then actually print like three zero. What's why? What? Okay. That's strange, no? It chose groupers, so you can't. I was pretty sure I can cast it to what the heck? This is just weird. Maybe I don't know the syntax for this one. Wait, that's just so strange. What if I don't overcomplicate it? I'm just making this. Now it's working all of a sudden. Okay, whatever. Okay, solve it. Longest prefix sequence, we're given a list of lowercase alphabet strings words. Return the length of the longest sequence of words where each previous word is a prefix. Wait, come on, that's just. I mean, this was discussed in chat. What the? Okay, whatever. Uh, what if we actually, like, part of me doesn't want to do that, but what if we go to, like, of course you should solve the problem, but at the same time you should not. You should not take such problems. No problem. Stupid. 7C0 error 3. Longest arithmetic sequence 3 paths. We're given a binary tree root. Return the length of the longest path starting from a node that goes to top to bottom, where its values form an arithmetic sequence. Okay. Should be some smart DFS. But a DFS should return like a map. Not sure exactly though. Also have just ants. I believe we have to do something like that. Longest path, right? So if not, but we return. Well, there's really no sequence, so we are just going to return an empty dictionary. What would I want? I don't have an arithmetic sequence actually. Great. Right. Somewhere around here, I want to return something like this. The if node has left child. Makes sense to speak about node ball. Like, what is the step going to the left? And also I want well, it returned a map of two. So if left div in left error left div gets div plus 1, I believe. It's just one, like you don't continue anything. We just have to change this to right, this to right, this to right. We don't have to change this actually. Despite it's looking ugly. But this, moment. Error certainly has some values. So answer gets max of answer and error values or keys. Keys. Values. Okay. Hmm? Oh, I see. I see. Zero. Otherwise, answer is at least one. Makes sense. Makes sense. Here is it. This is two actually, and it should actually get maximum of this. This. Oh, I should just copy this lines altogether. What do you mean? I just placed two here, no? I have not right. This here, this is here, this goes here. Oh, of course, okay. No? Let me quickly copy this here. Stupid. Really? What's going wrong? Uh, okay, good. So just like this, place number 3. Not bad, not bad. But I mean, it's somewhat not fair. Just look at the time taken, and also by the first place. Certainly notice that problem from C0 and 3. I mean, whatever. Yeah, it's certainly a fun contest, whatever. So yeah, let me pause that and let's walk through the solutions once again. Now at more steady pace so that I can actually explain everything. Because you know that I'm assuming that previous 15 minutes were not actually explanatory in any way. And I'm also gonna hide the chats because I think nothing interesting happens there. So for the problem, for the first problem, it's pretty confusing, and also this less than or equal to sign looks out of place. I believe that's actually how they write it in Russia. So in Russia, they prefer the slanted version, whereas in the US, they have like the straight one. It just looks odd, especially in fixed white fonts. But let's not get into these details. So it's worded pretty confusingly, but what we really want to do is we want to have one pair and everything else want to be in triples, right? So if you think about triples in pairs, you clearly want frequencies of the digits in the string or whatever characters are. It actually does not rely on the fact that these are digits. So the first thing we do is naturally take the counter of our string just to get the frequencies for free basically in Python. And now we want to check that these frequencies, if you map this array to frequencies, you will get 2 and 3. And certainly when you see a 3, you should group it into triples. And when you see a 2, you should get take it in a pair, right? But what if it's more complicated? What if it's like the frequency array looks like 2, 3, I don't know, 6, 5. You can say like, okay, 3, 6, easy. If we have elements of frequencies 3 and 6, we can just get rid of them. It doesn't matter. Like we can safely put them into triples. But then if we take this into a pair, then you see we get a problem because we have a frequency of 5, which doesn't really want to get into triples, and we already used our only pair. So at that moment, you think like, okay, so most of my groups are going to be triples. So I want almost all frequencies to be divisible by 3, right? And what is a bottleneck of this construction? The bottleneck is, of course, the pairs. You allowed only one pair, so naturally, you think like, if I suppose I don't take this into a pair, but I instead say, okay, 5 can be grouped as a triple and our pairs, and I have a problem here. To reflect this issue, we see how many frequencies give remainder of 2 modulo 3, because everything that is not a remainder modulo 3 can be grouped into triples, right? So the bottleneck is, or rather are, the parts of the frequency arrays that are not divisible by 3. And you want exactly one of them to be equal to 2 modulo 3 and none of them to be equal to 1 modulo 3. Because if you have 7 elements, there is no way you're gonna make them like one pair and several triples. Because if you make no triples, then you're clearly like another way to think about it is you got to make triples as long as you can, and potentially at the very end you want to make a pair. This actually leads us to a less Pythonic solution, but let's code it out just or should we? I mean, I'm assuming that you already see how to transform this list comprehension thing into like a normal solution that will work not only in Python. So I'm not sure if it's worth your time. But yeah, the key was the remainders modulo 3 of the frequency array. In the problem 2, I did it the bad way. Like, no, actually, yeah, yes. Okay. So the thing here is like it's your normal peaks, but you want them to be grouped together. So if you have several 5s in a row, they are either all peaks or none of them is a peak. So this just, it is just, oh, I have a debug statement and it still passes the time limit, whatever. Yes, because groups are not longer than maps, whatever. So the natural thing to do in Python is group by. It will automatically create groups of equal consecutive elements. And then I don't really care about like, the group by is actually designed if you have like a database entries or database-like entries. So for example, tuples, and you want to group them all based on the second element. Suppose they are sorted on the second element, like we have user ID, timestamp, and then some request information. And you want to group them by timestamps. You know they are already sorted by the timestamp. So you can just use group by to obtain the groups of users that issued some request on the same timestamp. Because probably you want to, like, I don't know, execute all of these requests simultaneously. This is sometimes async in these problems. So this is a natural idea that comes to mind. But in case I have just numbers, I don't really care about the second element of the group by. It's actually, I believe, an iterator over the tuples or whatever objects you had that got into the group. The only thing I care about is the length, is how many elements I have. But because it's an iterator, I have to convert it to a list first and then take the length. So after this, it becomes pretty straightforward. Apart from that, I did not read this statement. So I got this hash key strong on the first try, and it was pretty clear. The way it is coded is terrible. You should actually make it like a so. And no, not here. Perhaps the only time when you're going to need parentheses in Python is like so. I believe this can all. This is why we got, I don't know, third place and not the first place, ladies and gentlemen, because I'm stupid. So actually you want to check if there is an element on the right, and if so, then if it is less, and you don't want to get this, to process these cases separately, which was a bold mistake on my side. I will hopefully not do this again. And we also needed a counter J just to like keep track of what is the current index, because we discarded all of this stuff. So yeah, just in case we want to append something, then we have to walk it one by one. But if we don't want to append to answer, then we can just skip. I believe this makes no real difference whatsoever, but I decided to skip. So yeah, the key idea was to group numbers consecutive together, put them in a list because you want access to neighbors, and then do your thing. Like your normal big solutions goes here with the index J. So for problem 3, I don't really know what to say about it. It was discussed a couple of days ago in the coding problems channel. I don't think it is legal to have contests like this, but apparently other people also knew this problem. Judging on the 30 seconds to accept a verdict, you clearly can't code this even if you have like, I don't know, 2 words per minute typing speed. Just you got to think about this one. Okay, so the problem is that you have some words and you want some sequence, not necessarily a subsequence, but just some sequence in some random order that goes like so. So you have A, B, A, B, C, A, B, C, D, and the thing is you append one character at a time to the end. Like my original idea when I first saw this problem in the channel about coding problems was to like it's simple dynamic programming on a try. You want to put your words in a try, so it goes like so. There is a start vertex. There is some start vertex, and in our case we have letter X is the first letter of some words. Letter A goes here. From X you also have Y that goes to some other vertex of a try, and you have B that goes here. So actually in a try, like your transitions are labeled by letters. And for example, if I believe we also have A, B, C, D. There are levels. So like first level, starting level, first level, and second layer, third layer, etc. Let me pause this a bit. So that, like, every edge has a label that corresponds to a letter that has such nature. So if, for example, we had a word x, z, then it would go here. And if we have like a, b, e, or probably, let's say a, b, e, f, actually to make things more interesting, it would go here and then here. And then there's also one important thing. You want to label each vertex that corresponds to an end of some word. For example, vertex, this one won't be labeled because I said that we have A, B, E, F, but not A, B, E, right? So in our case of these words plus X, Z plus A, B, E, F, we have these vertices are terminal. And then you basically want to like do a dynamic programming, which is actually better phrased as a DFS by C0R3. So what you want to have is like you walk in a DFS order and you say like, what is the answer here? Oh, it's one. And instead of building this chain like this, and then this, and then this, you walk your normal DFS, and then you propagate answers to the top. So you propagate answer backwards, and this works efficiently. So when we are at the leaf, we know it for sure it's terminal. So the answer is one. It forms all by itself the sequence, the valid sequence of length one. And we process them in a post order, I believe. Or actually, we can do it like whatever way we want. It's what we know with the answers for all children. There are not that many of them. And we can check if this vertex is an end vertex of some point, of some word, then we can increment the longest chain that our children have. So the answer here is 2. Same way here, the answer is 1, answer 1. Here the answer is 2 already, A, B, C, D, and A, B, C. Here the answers become 0. So when this vertex takes max, it doesn't see this vertex, it just sees immediate children. For the answer is 3, 0, and 0. But for the answer in general, it's not the answer in the root, it's the answer, the max answer, the max value we encountered during the DFS. I believe C0R3 actually computes the path itself, which is not really necessary. Pass. Whatever that is not necessary. And I also prefer it to be structured this way. No, actually, I prefer this statement to be here. Does it really matter? Like, hold on. I don't think you need it, actually. Also, this, like the typical, so I have here. Sure, I understand what's going on. But this is not necessary for sure. With it is not necessary. We don't have cycles in our graph. What's going on? Yeah, let's write a normal solution for this one because this is just cut it. So we have a graph. A graph is default dict list and not whatever you want it to be. For working words, we actually want like word set is going to be the set of words which we need because we want to quickly check if some vertex is terminal, is the short answer. While word I want to pop the last character from the string. I'm not sure if it's gonna make it. I'm pretty sure it's not gonna make it. Can you make it like this? And here we want to add graph words all but last append of words. So like this should generate all the transitions. Including from an empty character to whatever that is. Actually, now that I think about it, should be just set. Because I don't want to duplicate just in try. Longest pass. I should compute the pass here. What is the pass? The pass is maximum of word in words set. Then it is maximum plus 1, or actually 1 plus maximum. Else it is 0. Here I want to give as next word in graph word. If it's 0, if we don't have it, I'm gonna say it like this: if word in word set and graph words L0. Longest pass get this, and we want to return the pass. Is it gonna work? Words set. Why actually? Oh, because if graph words is okay. I was wrong a bit. So if word is in word set, if graph word, if it has children, then we want to return this thing. Else it has no children and we can return 1. Or actually not return, but pass gets 1. Because we need to can't pass here, otherwise, no, actually else. Pass gets 0. So from A to AC, from empty character to A, from A to AC, so we should call DFS from of AC. It is in word set, but it has no graph. Right, so we should, well, let me just print word pass. Hold on, what do you mean? What do you mean? How did that happen? Like, okay, I understand empty word and pass of 0, but where are the recursive calls? Like, I clearly made a recursive call here. Oh, because I want to make all of these recursive calls either way. It's not in word sets. I still want to call them, but I just don't want to count them towards the answer. Right? I'm assuming that this is a bit is going to, well, this kind of works. And because the word is so long, that this operation works too long. Well, that's kind of unfortunate that you can't do it this way. So what was C0R3 doing actually? Like, of course, you can change strings to like to build an actual try, not the way I did it, but the normal way. I believe that, oh, he only has transitions between words that are like directly adjacent. Oh, this is also the way to do it. Okay, whatever. Like, so we don't build exactly our try. If you remember this part, then C0R3 is actually not building any of this. And not even this. He just builds it like so. Only these parts of a try are constructed. And then he, because he starts DFS from every word, this also works. He starts it from here, and from here. But this also should be not very good, I believe, if like you have to slice a string. Slicing can be fast if you have too many long strings that you want to slice. Oh, I guess slicing works in the total time, in the linear time, in the size of all strings, which makes sense. Okay. So you either had to build a try from top to bottom, adding one character at a time, not deleting one character at a time, or you can do this. That's clever, actually. Okay. Good, we copy pasted it and not like tried to implement from scratch. I mean, I would probably construct try from top to bottom. I just saw this and I thought like, oh, this works and we're gonna do it the same way. But it only works if you like very careful with what you're doing. Okay. Yeah, but either way, it was like try DP. I still think of this like a try DP because it is just like it's more explicit way of saying what exactly you're doing than just DFS. DFS on what? On what graph? On the graph of words? Well, probably. But you should be familiar with the concept of a try. And the last problem is another DFS, which is not great, I think. How do you call a step of arithmetic sequence? Difference? I can't think of a different name. Oh, I forgot. So the idea is more or less simple. Like you again want to check if a sequence that ended at your, no, actually you want to check like for a sequence, well, let me draw something. Suppose I have a tree and it goes like this, I believe it's going to be enough for the construction. Actually, we can take, oh, we can't, that's okay, so this should work. So if you look at this vertex, you don't really see any sequences, right? So you return an empty map. A map is going to have the following values. It has like difference and then length. The difference of arithmetic sequence and then how long you can make it. Obviously, you want to max length and not just any length. So at this point from here, we return an empty dictionary, which is completely fine. And when we are at some interesting vortex, and by interesting, I mean having children, and then it sounds like, okay, difference here is 4, difference here is 3. This vertex can't continue a sequence of 3. This vertex can't continue an arithmetic sequence of difference 4. So I'm just gonna take 2 as a length of my sequence, which is here. In the same way, so it is going to return a map having 2 keys, 4 and a value of 2 corresponding to it, and then 3, 2. And this thing is going to return, I don't know, this thing going to return here a map from 3, 2, and then from 2 to 2. And when this vertex looks and gonna say like, okay, the difference here is 3, and this vertex actually knows how to continue a sequence with difference 3, and this is this path. What it doesn't know is about the path, it only knows that it can continue. So it adds 1 to this answer, and it's going to have an answer of 3 of length 3, and then here it also can continue the length, the sequence with a step of 2. So it's going to have 2 with a value of 3, and just takes max of values here and puts it into answer. Just returns. And each such map has at most 2 entries because we have a binary tree. Otherwise, if we had like an array tree, and you would actually have to think about how do you want to merge these 2 guys. So the answers returned by children. And this is actually a fascinating idea. If you merge smaller to larger, then it also works in almost linear time. It is either n log n or n times something like 4, which is inverse Ackermann function, but we don't really want to get into the details here. It's basically how the path compression works, I believe. No, not path compression, but the rank statistic, the rank, what do you call it? Heuristic, right? The rank heuristic in disjoint union works the same way. You merge smaller to larger and you get decent running time. So it should be, by itself, it shouldn't be n log n. But here we have a binary tree, so we don't have to think about anything. We just have to write a straightforward tree DP, or which is normally formulated as a DFS. So that's how we got rank 3, I believe. Let me clear anything. I don't really want to pause this solution. It's worded pretty badly. I believe you can do it much better. Okay, so a lot of people finished. Yeah, basically everyone. Oh, poor Laurie didn't know it was posted before. Sad. Okay. Imagine being C03 and not participating in this contest. Oh, he did. Okay, he got stuck here, but then copy pasted his solution. Okay. Or maybe did not copy paste. Actually, in 1 minute you can type it completely, but also we have pretty serious competition going on. Like Pichula is grandmaster in Code Forces, I believe. Also didn't know about this thing, but is much faster to type easy things. Actually, that's pathetic. I mean, whatever. Oh, I actually should make that solution good, but it's not going to be right now. Someone is joining contest. Too late. That's not what I can tell. I wonder how that happened. No, it's actually not an easy problem if you don't have group plan. Okay. So I guess I'm gonna put the code in here to get the screencast uploaded faster. And with that in mind, see you next time. So hopefully next week. Or maybe we are going to see each other in just a few minutes in the chest room. Bye bye. See you soon, guys.